Welcome to Aquabotz 101. So in this segment of Aquabotz, we're going to learn how to design, build, and operate a working underwater robot. So this right here is not the one that you're going to build. You're going to build one with other pieces and parts that we'll go over later. But this is a video ray. And video ray is built around several premises, and these are things that I want you to learn to work into your design for your Aquabot. So many of you came to school or wherever you are today in a vehicle, and that vehicle was designed to be safe. You're supposed to be safe inside, right? So that goes to the frame. The frame is the part of the ROV where everything is attached to, right? And it's also, the frame is also has the parts and pieces that protect it from harm, like the propellers. You have these cowlings, right? So the parts that keep the ROV working are the frame. The frame keeps all the pieces that make it work together, and the pieces around it keep the things inside of it safe. Very basic. Okay, what direction do you want your Aquabot to move? You want it to go forward? You want it to go back? You want it to be able to turn to the right, turn to the left, back to the left, and back to the right. You would also like it to do this, turn on its own dimension, right? The question to you is, how many motors does it need to be able to move in all of those horizontal directions? Note that we didn't even talk about the vertical movement of it going up and down, which is the fun thing about things in the water, that not only do they go this way or that way, but they also go this way and that way. All right, so the question to you is, what's the minimum number of motors you need to make this thing move in all the directions that we said? All right, so when I say turning, usually on a boat you have a rudder, and this doesn't have one. I'll embarrass it by turning it upside like this, and see, there's no rudder on it to move. So that means you have to use your motors to make your turns. So how do you do this? You have horizontally aligned motors, and this is your starboard or your right motor looking forward, and this is your port motor, the motor on the left looking forward. And I know you get confused about starboard and port, but let's just say this: port and left have the same number of letters, so that makes it easy and impossible to forget, even for me. All right, so now here's your Aquabot. All right, and in order to go forward, we put both motors on, and both motors go forward. Both motors back, and it goes back. Now, what if? What if we just put the starboard motor on? The starboard motor on, I'll do this upside down to make it easier. If we just put this motor on, that's going to make a lazy turn to the left, or to port. If we have this motor on and not this one, it's going to make a lazy turn to the starboard. All right. This motor going backwards, this motor going backwards. Right now, what if you put this one forward and this one back? Then it's going to turn on its own dimension. Opposite. So what's the minimum number of motors you need to make it move in all of those horizontal directions?
2.
Excellent, Daniel, 2. Now, you want a motor vertical that makes it go up and down, right? I call that the vertical motor. Not too difficult to remember that. All right, so the vertical motor goes up and down. Now, where do you want it placed, Dan? You want it placed all the way back here, in the middle, on the front, or right in the middle?
Right in the middle.
Why is that?
I don't know, Doug.
Well, if you put it back here, then it's going to tilt going up, and it's going to tilt going down. If you put it all the way in the front without any weight on it, going up, it's going to do this, or like that. If you put the motor right in the middle, then it's going to hold its horizontal position going up or going down. Is that clear?
Yep.
All right, excellent. Now, so with that, with 3 motors, you can have it move in any direction that you want. clear?
Yep.
All right, let's talk about buoyancy. Positive buoyancy is where things float. Negative buoyancy means it's going to sink. Neutral buoyancy is when it stays in one position. All right, so why is that important in an ROV? This is the tether. The tether connects the ROV to the surface and the operator. Now, when it's positively buoyant, the ROV will come to the surface, it floats. When it's negatively buoyant, it sinks. When it's neutrally buoyant, it stays put. So what happens when the tether gets cut? And when I say cut, let's say the work that I've done, a shark comes up and bites it, or it gets caught in something and it gets cut off, right? If that happens, what do you want your ROV to be able to do? I'm asking you. Do you want it to sink? Do you want it to stay where it is, or do you want it to float?
I want it to stay where it is.
Well, I'm thinking that if it gets cut off and you're in 500 feet of water, and this one here is $45,000 worth, and the ones that I've worked with are up to $2 million worth, I'm thinking that if the tether gets cut, you really do want it to be able to float.
Right.
So you should design your Aquabot so it's slightly positively buoyant. All right, so your design of your Aquabot is not just about designing it so it swims. You want your Aquabot to do something. This is called an observation bot. And what it has in it, it has a camera in the front. It also has these things. Lights, because it's dark underwater. All right, so in your Aquabot, we do have cameras that you can put in so you can see forward. Where do you want your cameras to be? Do you want them just forward? Do you want a second camera? Do you want a third camera? Where would you put it? We have a second camera behind in this ROV so that when we're flying it in tight quarters, like in a shipwreck, in a hallway, where if I turn it, I'm hitting the walls, I can see behind it so I can back it out. So ideally, you want tools in your ROV. In this one, an observation ROV, I've got a camera in the front, a camera in the back, and I've got lights. I've worked with ROVs that have toolkits, wrenches and things like that. And welding, you can do anything you want with an ROV. All you need is money and time and engineering to create the ROV that will do the things that its mission is asked to do. Hey, welcome to Aquabotz 101. What we're going to do right now is let's show you the controller, and then we're going to show you the parts that go to building one. So let's start with this. The Aquabot is a DC system and it works on batteries. And batteries are very safe. You should never worry about working with batteries in terms of electrical shocks or things like that. So like this, if you do this and you do this, no, really, it's completely safe. There's nothing that would harm you. You can do this. Honest, try it yourself. So this is 12 volts coming through here. It's not going to hurt you. It's very safe. Just don't cross the wires because you will get shocked or make sparks. So let's hook these up. And you see we have a red and a black, but that really isn't important right now, especially with this mechanical or electromechanical system. So I'm going to hook this up. I'm going to hook this up. And here are your three motors. All right, and here's your box. And in order for this to work, you need to turn it up from off to on. Right, and then it will move or work all these thrusters. So you see with these double pole, double throw switches, I can move this that way and that way, and it would go forward and back. Note that when I do that and let go, it stops. These are called moment switches, which means that they have to have a force to keep it on. All right, so if you're going to move your Aquabot forward, both go forward, both go back. All right. Now, what you didn't see the one in the middle moving. That's this switch here, right? And so if I turn that on and I use this rheostat here and turn it, I can adjust its speed or its velocity, right? I want to reverse it. I go to the off position and then back, and I turn it up or down. And that's the motor that will make the ROV go up or down. All right, enough of that for now. When I stop, I'm going to disconnect it from the battery so it's safe. All right, now what we're going to talk about is what's inside here. Now, the way to look inside is you pop the tabs of this former sandwich box, and you can see inside all the systems that you will create when you wire this up. So the different orange, the different blues, the different wires are part of what makes this go. Okay, we'll go through that. Let me button this up here. And this is pretty waterproof. I say pretty waterproof, it's not altogether waterproof, because it's got a hole in it, all right? But it's pretty safe. All right, that's that. So let's look in the box here and see all the pieces that go into making an Aquabotz controller. All right, we can start with, this is the sandwich box, so it's become the box controller, and this is the top. And this all comes pre-drilled and pre-labeled, so you don't have to worry about that. All right, so the Aquabotz, the motors, are made of these. These are bilge pump cartridges, and you have 3 of these. You have these doohickeys here. These are prop adapters, and you will be shown how to use these to attach your propeller to this. This gets attached to the bilge pump cartridge, and it creates your tether or your motor. Right? These are your propellers. This is your magic rheostat, and this, you turn it and it will create the velocity for your vertical motor to go up or down. Actually, when it's off, it's not the motor turning that causes it to go up, it's a slightly positive buoyancy that you build into your Aquabot that causes it to float magically. This is your on-off switch, where if you turn it in one direction, your bot goes on, you turn it the other way, and it's off. This is a single pole, single throw switch. Temflex tape, you learn how to use this to secure your cartridge to the brace. Your U-clamps. These are the switches that you will design into your Aquabot controller. Right? And note that this switch here is pressed into printed circuit boards and then the switch connectors. And this circuit board allows you to do this changing of the poles, to change the directions of the motors without using soldering. So these printed circuit boards were made especially for this switch. All right, so when you design your Aquabot, when you're done, it's not going to look quite like this, all right? But the piece that you use will emulate this pretty damn well. I said damn.
Wow.
Okay, so we have 6, these are PVC, 1/2 inch, schedule 40, and we drill it out because we want the water to come in here. We don't want the water or these pieces to affect its buoyancy. The buoyancy of your Aquabot will be calculated using these pool foams. Right? Note that in video ray that the foam or the buoyancy is on top, not on the bottom. It's on top, right? Because when this is floating, you want your propellers to be in the water. If it was the other way around, like a boat where the buoyancy is on the bottom and your propellers were out of the water, right? They wouldn't be in the water and it wouldn't be able to work inside water. So the frame pieces you have these 6-inch straights which make up your frame, and then you attach these. This is a 1, 2, 3, 4. This is called a 4-way, and how this works is you push it on to your 6-inch to create a Lego with steroids type of frame. These are 3-ways or corners. There's the corner. So you could use this to create a box, which is a basic design of an Aquabot. And I say basic in that this does not mean that you have to design it like this. We're just showing you how they work, right? Don't listen to me when it comes to design, because you can be much better at this than I am. All right, so once you create the frame, then what you'll do with these pool noodles is you'll put the foams on top, and we'll secure these with plastic cable ties. Let me show you. We have these, and in order so these don't float away, you put a cable tie around it, tighten it up, and that will become the flotation for your Aquabot. Okay, so that's the frame. And just as a trick, not that I'm trying to influence how you do things, but just note that this 6-inch PVC here can be integrated into the frame. So you take these 4-ways and put them in here, and then you can add these any which way you want to build your ROV frame. How cool is this? What if you put your up and down motor right there? Right, note that in this design, the propellers are inside the frame, because the frame, if you remember, will be the protection of these from the outside sources. Like if you hit the side of the pool, these will not hit. Or if you go to the bottom, this will not hit the bottom. Got it? Is that cool? Is that clear? Okay. So those are the frame pieces. So now you know the pieces, you have the controller, you know how the controller works, you know the frame, the pieces that you can design. Now, go make your own Aquabot. Now.
Hi, I'm Dan Ortiz, and for the duration of this video manual, I'm going to be the one instructing you on how to make an Aquabot. Now, before I go into any of the actual instructions on how to construct the Aquabot, I'm going to introduce you to the newest edition of the Aquabot's design. This is the battery pack. Now, the battery pack introduces 2 new functions which are not present in the older design. Now, in the previous little segment, you were introduced to all of the parts of an Aquabot, and also all of the functions that it has as the design allows it. Now, one of the things that the Aquabotz requires is that it be connected to a 12-volt battery. Now, that 12-volt battery was connected with alligator clips. Those clips are not necessarily the most ideal. They're prone to fall off from time to time, and it also keeps the battery near the water's edge. This battery pack negates both of those issues. The battery pack houses the battery within this front pocket here, and instead of using alligator clips, we use a non-polarized plug, and on the end of the Aquabot's power cable, which is connected to the plug here. Now, there's also a second plug. The second plug is used for the fish cam. So here I have a fish camera. Small fish camera, which gives you visibility under the water, and it also has a series of high-powered lights mounted inside of it, and it connects to a monitor. Now, this monitor is held by another person while the operator of the Aquabot controls it. Now, this monitor originally comes with its own battery source that has to be charged individually from the 12-volt battery that powers the Aquabot. Now, this new design gets rid of that other battery source entirely. Here I have the fish camera's power cable. This connects directly to the monitor and connects to the other plug on your battery pack. So now that you get an understanding of all the different components that you're going to be able to construct the Aquabot, the battery pack, and how it allows you to use the fish camera, we'll go ahead and start with building the tether.